Okay, hello everyone. Now in this video I'll be working on, I believe this is worksheet 6, definition of the derivative. Now before I actually get into working these problems, I would like to just share with you how I actually go about in, let's say, just creating these types of recordings. I won't be able to show you everything, but I'll show you what I actually can. Now, what I'm using actually is the Edge browser. It's a browser that comes with all laptops once it's Windows. And this is actually a PDF document that I would be writing on, wherein I can just use the tools that I actually have here for Draw. And this allows me to just generally write on it. Now, how do I write? I bought this tablet probably 3 years ago because I do graphic design every now and again, just as a hobby. So I paid around $21,000 for this back then. This was like 2018 or 2019, and I know a lot of persons say that that's a little bit expensive, but as a teacher, this kind, well, it actually comes in very handy when you have to be teaching these online sessions. So this is the lowest I can actually suggest. This is around $40. It will come like around $12,000. Similar to what I actually have. It's a drawing tablet. And it's going to take you like probably a week or less to understand all of the features that this provides. Now, in order to create a PDF, I actually use a software called InDesign because I do not have any Microsoft Office applications on my computer because I abandoned that years ago because I don't really use it. I just use graphic design skills to create whatever it is that I have to create for any presentations or the like. Now, in terms of recording the video, there is a free feature on Windows laptops that actually allows for you to record. It's a little bit of a trick to make use of, so I wouldn't really recommend that. You need to look at third-party software in order for that to be done. So that's just generally the gist of it. So I'll be working all 10, actually 11 questions, but for number 11, I would suggest that a lecturer during a tutorial session or otherwise break this concept down a little bit better, because the definition of derivative to show this, it should be undefined, but it's best if a lecturer actually explains it to the class. Now for these problems, I'm going to be using just derivatives, no force principles. I'm just going to work and solve. Some of them are actually a little bit technical, but they're manageable. So the first one, let me write this here. I can remember it already. Y is equal to, alright, I forgot. Minus 2x plus 5 minus 2x plus 5. Now before I actually continue, when I make these videos, what I have started doing is I have chapters there. So for those that are already skilled in calculus and you just want to, of course, just look at a particular question, it's outlined in the description box. Now, a lot of persons don't read the description box, but it's right there where I actually just have a simple outline that I'm just doing this here to assist. And then there's the contents of video that I have there. And each point there is a timestamp. You click on the timestamp and it carries you straight to the part of any of the questions. Alright, so let's now go into this, dy dx. Alright, we know the derivative of a constant is 0, so I'm not paying attention to that, so I'm left with minus 2. Now most of these questions on this worksheet are like, for me, one-line questions. Some person might need to do two or three, yeah, one line for me. This is just the question, this is one line. Some person may take 2 or 3 to actually arrive at the answer. So next is f of x is minus 4x minus 2. So f of x equal to minus 4x minus 2. So dy upon dx is equal to, derivative of constant is 0. This is 1 minus 1 times 4. You write this better. We said minus 1. It's 1 times minus 4, which is going to give me minus 4. Alright, so that's number 2. Number 3 now. 4x squared plus 1. As I said, these are relatively easy because they just want you to just use your skills at this point in order to solve these questions. Y is equal to 4x squared plus 1. So dy upon dx is equal to 8x. Alright, so maybe moving too fast for the persons that I'm actually making this video for, but it's Saturday, it's early, kinda. Don't pay attention to the time that I have up here. That's another country's time. I'll do this one slowly. So y is equal to 4x squared plus 1 dy upon dx. Power comes in front, times 4, x, 2 take 1. Derivative of constant is 0, so 2 times 4 is 8. 2 take 1 is 1, so 8x. Alright, so that's your comfort area, but I'm going to start working back the questions now at full speed. So minus 3x squared plus 4. Y is equal to minus 3x squared plus 4 dy upon dx. So 2 times minus 3 is minus 6x. I do apologize for the noise that you're actually hearing because my nephew is home and, well, he just likes to talk. Of course, he's like 4. He loves to talk a lot, so you're hearing some chatter every now and again. Alright, next is minus 4x squared minus 5x minus 2. So y is equal to minus 4x squared minus 5x minus 2. So dy upon dx. 2 times minus 4 is minus 8x. Again, when you see this here, just write back the number. When you have, as I would always see, number and letter. So we have here now minus 8x minus 5. Alright, so y is equal to 3x squared plus 3x plus 3. Yeah, see, as I said, this is kind of easy to work through. Y is equal to 3x squared plus 3x plus 3. So dy upon dx. 2 times 3 is 6. Have an x plus number and letter. Just write back the number. Again, yeah, remember I'm not using scale. I'm just showing you some of the tips that you should already have mastered at this point. Now, this is where things become where I have to work it slow for you. So y is equal to the root of minus 3x minus 5. So here we go. Y is equal to the root of minus 3x minus 5. Now, whenever you actually have something like this, I would always suggest that you do this first. You do this, you put the x, power here is 1, this goes in the numerator. Here is 2 because it's square root. So that's where you could actually remember your structure. So I'm going to have to write this now. So I have minus 3x minus 5. And like before, this is going to be in a bracket. And I have the power is a half because it's root of that. Now, stepwise, dy upon dx is equal to a half of minus 3x minus 5 raised to the half take 1, which is being multiplied now by what is inside here. And the derivative of minus 3x minus 5 is going to just give me minus 3. Good. Again, so this is like a two-step process you need to do. You do derivative of the entire thing with the power, then you do the derivative of whatever is in the bracket. So as you continue to work more calculus problems, those brackets are very, very important for you to pay attention to. So let's look now at, yeah, I'm teaching a class with teach my grade 9s now. Yeah, let's look at what we have here as a fraction in the number. So we have half times minus 3. This is going to give me minus 3 upon 2. It's minus 3 that I have to use, right? Yes, good. Minus 3 upon 2. So I'm having here now minus 3 over 2. Bracket, because remember the bracket is still here, minus 3x minus 5. Close bracket. A half take 1, working this out for you quickly, is a minus a half. So automatically this tells you that this entire component that's here needs to go to the denominator in order to make what we have here a positive power. So dy upon dx is equal to minus 3 over 2, open bracket, 3x minus 5 raised to the half power. Now something to take note of, and this is what I actually was looking at in earlier videos in terms of the answer. You would want to simplify this by actually writing it in roots. So when I say that, you have 2, the root of 3x minus 5. So if you look at the top here, similar. Actually, it'll be negative 3x minus 5. So it's starting to rain. Just give me a moment, I need to just close these windows. Number 8, f of x is equal to root of 4x take 5. Alright, so f of x is equal to the root of 4x take 5. So dy with dx. Oh, I shouldn't do that now. Now every time you see these problems, you need to always write the fractional power. Once you see that root sign, always write the fractional power first. So f of x is equal to 4x minus 5, which I'll put in bracket, and the power is raised to a half. Now, the power is not always going to be raised to a half. It's based on the nature of the question. So just give me a moment to pause here. Let's say you have b squared. Under the root sign in here is, let's say here is 5. This would be equal to b, the power that's with under the root is numerator. Whatever is written here is the denominator. So this is just for these types of questions where you just see the simple root sign. So dy upon dx is equal to, bring this in front, half, open bracket, 4x minus 5. So half take 1, which is multiplied. Now, I use asterisks for my own personal reasons. What's inside here? Derivative of the constant is 0, so leaving me with 4. So I have a half times 4. I don't think I need to actually work that out. Yeah, just take a simple break and my thoughts are all over the place. Alright, so this is dy over dx is equal to a half of 4 is 2, open bracket, 4x take 5. Right now this is going to be minus a half from the earlier question. So dy upon dx is equal to 2 being divided by 4x, subtracting 5 raised to the power of a half, and this is equal to 2 over the root of 4x minus 5. Alright, So we have now some doozies to work with, number 9 and number 10. Y is equal to 1 divided by x plus 2. So y is equal to 1 being divided by x plus 2. Alright, now, like before, you need to rewrite this. Now, because this is in the numerator, I just bracket it off. Power here is going to be 1. So in rewriting it, now 1 is equal y, sorry. Yeah, that's a simple break. Right, I'll slow down. I'll have 1 bracket x plus 2. Now since it's moving from the denominator now to the numerator, minus 1. Moving on to the next step, where I would be deciding derivative, I'll have minus 1 times 1 of x plus 2 minus 1 minus 1. Remember, we have to subtract from minus 1, which is going to be multiplying derivative of what's in the bracket, which is going to be 1 because it's just x. I think I should probably just do this because I didn't do it in the earlier video. But variable by itself means the power is 1, so this is 1 times x, 1 times 1. So this is basically 1 times x to the 0 power, which is 1 times 1, which is going to give you 1. So, what do we have here now? dy upon dx is equal to minus 1. Alright, I'm not going to spend too much time. Here this is minus 1 when you multiply them together. And this is going to be times 1, which is going to give me minus 1. Then we have x plus 2 and minus 2. So, next step, dy upon dx is equal to minus 1 being divided by x plus 2 squared. Now, I would leave it as this. Some persons may choose to expand it out. I guess this is based on the lecture or the style of how the answers will be needing to be answered in Moodle. Alright, so the last one, f of x is equal to minus 2 divided by 2x minus 1. So, f of x is equal to minus 2 over 2x minus 1. So, f of x is equal to minus 2 bracket 2x minus 1 raised to the minus 1. Yeah, so it's very similar to what happened before. Yet we're going to dy upon dx now is equal to minus 1 times minus 2 of 2x minus 1 of minus 1 times minus, what am I doing? That's minus 1 times. It is minus 1 minus, let's give me a second, system froze, yes, minus 1 times derivative of what's in the bracket, which is going to be 2. So I will be doing this again. Minus 1 times minus 2 is going to give me a positive 2. So 2 times 2 is going to give me 4. So dy upon dx is equal to 4 bracket 2x minus 1 minus 2. So dy upon dx is equal to 4 over 2x minus 1 brackets squared. Again, some persons want to expand it out, but I leave it there. Now, the last one. Use the definition of derivative to show that f prime 0 does not exist, where f of x equals the absolute value of x. Alright, you know what? I think I'll just let the lecturer complete this one so that he can probably explain it to anyone better. My skills in this area are not the best when it comes to explaining, so with that being said, I hope you enjoy the remainder of your day. Bye.